taking a look at 4.2, which is acids and bases in chapter 4. So we'll get to the definition of acids and bases, but they use the word neutralized, so it's kind of 6 one, half dozen of another on who we define first. So something that is neutral, it has typically a pH close to 7. So approximately 7 is what that is. So not equal to, but approximately. So around 7. We can also say neutralize, which means to bring the pH closer to 7. So maybe we had something that had a high pH and we lowered it towards 7, or maybe we had something with a low pH and we brought it up towards 7. By moving that pH closer, we have neutralized something. When you add an acid to a base, you neutralize them. Here's the definitions of acids and bases. So acids and bases, obviously, we've categorized for quite some time. And what they did is they made lists of properties that they knew to be true for acids or bases, because not everything can be tested. Some are quite hazardous. So by defining a set of properties, we could test one that might be less hazardous to do, and then assume it falls into the correct category. So acids typically taste sour. So examples could be lemon juice or vinegar, orange juice. Acids turn blue litmus red. So we can see that here. This is a blue litmus paper and it's been dipped here in this solution and it's turned red. It looks a little bit pink, but this is red. When blue litmus turns red, we know it's an acid. Typically what we'll also do is we will test it with red litmus beside as well, and red will just stay red. It won't change color at all. Again, it would look something like this. Acids react with metals. So if I put a metal in the bottom here, so maybe a piece of aluminum, it would actually start to bubble. So we can see that it's reacting. Acids have a pH less than 7. They are corrosive. They neutralize bases. So if I add an acid again to a base, it will bring its pH closer to 7. And acids conduct electricity. Bases, on the other hand, taste bitter. An example of a base is actually baking soda. And if you tasted baking soda, it's kind of gross. Other examples are soap, and that's why bases feel slippery. Soap is made out of a base. So if you've ever tasted soap as well, it tastes bitter. In a base, red litmus will turn blue. So we can see that down here. We have our red litmus paper. We've dipped it into this solution, which must be basic because it has turned blue. If I had a piece of blue litmus paper beside it here, blue litmus would remain blue the whole time. I guess I could draw this. Bases don't react with metals, so it's not listed here. And acids don't have a particular feel, so they don't have anything listed in terms of feel. Bases have a pH more than 7. They are corrosive. They neutralize acids. Obviously, when we add an acid to a base, it becomes closer to 7, and they will conduct electricity as well. How do we identify them? Well, we can use some of those properties, but we can also use indicators. So indicators change color in the presence of an acid or a base. Like we just said, these litmus papers have been changing in the presence of an acid or a base. Other examples that are a little bit more natural are flowers. Hydrangeas will change between a pink or a blue color depending on the acidity of the soil. Lichen, which is like a kind of like a mossy covering on rocks, if you will. Cabbage juice can be made. You boil cabbage till it smells really bad in your house. And that cabbage juice, once strained, will change color depending on what is present. Some types of tea, grape juice, there's lots of different things that are actually indicators. The most commonly used indicator is litmus. And again, it's made from this lichen. Litmus paper is just paper soaked in that litmus solution. We can also use what's called 0 to 14 pH paper. It's a different color for each pH value. So you would dip that piece of paper, just one piece of paper in. It starts white typically, and it will turn a different color depending on the pH. So if it turned like this really nice teal color, I would try and match the color that my paper has changed to this little scale here. So the pH scale tells us how acidic or basic something is. It is a range from 0 to 14. However, don't think that it has to be between 0 and 14. We can actually have negative values, which is terrible, and values beyond 14. Those are just super acidic or super basic compounds. Acids, we know their pH is less than 7. Sorry that my image is so blurry here. Bases have a pH greater than 7. Bases can also be said to be alkaline. So this would be basic. And neutral is around 7. So typically we say like 6, 7, 8 is neutral. So to try it in lieu of a lab, because we cannot do them, click the link below to complete the pH analysis for a variety of household compounds. I've put a link directly below this video in our Google site, if that's where you're accessing this, to log in. So just a note, we're accessing this through our regular Moodle, not the Moodle we've been using or you may have been using for other courses that we started with in this class. If the link doesn't work the first time, follow the link to this once, log in, and then come back to our window here and retry it now once you've logged in. It should work. Fingers crossed. Please send me an email if it doesn't. Complete the questions on the next slide and then maybe keep them somewhere handy until the Chapter 4 quiz. These results may come up on that quiz. So we're going to complete the following table by selecting the substance in a drop-down menu, click test, drag the test strip to match it to a pH value. So you're looking at a pH scale like that pH paper from 0 to 14, and each individual one has its own specific color. So you're going to test each of these substances here. Decide using this scale what the color represents in terms of a pH value. And then using that idea, ask yourself, is it acidic, so less than 7, basic, greater than 7, or neutral, around 7? Okay, you could label something from 6 to 8 as neutral. That would be fine. A little bit of practice here for you, page 69, number 1, 3, and 4.